Hi everyone. So if we move to the which arrow should I use? Back. So I'll be quick on the abstract. Just to mention that 50% of the Canadian landmass is underlaid by permafrost in different states. That's what is shown here on the map. It can be continuous, discontinuous, thin, thick. And it shows you, that map shows you where we were working. So it's include onshore and offshore areas in Yukon and NWT. Project members, what I want to underline here is the disproportion of GSC staff versus external collaborators from international organization and the academia. Without them, this project would never have succeeded to the level it succeeded. And I want to also highlight the contribution of Michelle Cote at GSC Pacific for the permitting engagement. She was a key player in that. Scott Dallimore, who now retired, was in charge of the onshore part of the project. Just a bit of the context. So obviously, we all know that global warming is occurring, and the Arctic is highly impacted by the increase of global temperatures. And by increasing the temperature, you're getting all those different processes that are triggered by permafrost degradation, and those processes do occur onshore and offshore. And for those who don't know, we have offshore or subsea permafrost as well that was formed when the continental shelf was exposed to the extreme Arctic conditions. So I decided to go this way. So I thought, 5 years long project. So I selected 5 key realizations. 2 of those are report work that were done onshore, where Scott Dallimore of the GSC was involved in, Roger McLeod as well, James Zeng as well. And there's one paper that shows 2 papers that report work that was done offshore, and another paper that report work done in the lab. So the first realization is by Laura Lafemme from the University of Maryland. Well, she studied the microbial production of methane that was associated with permafrost degradation. It involved field work, obviously, permafrost drilling, looking at permafrost outcrop as well, and different permafrost conditions were defined. And from that, obviously, samples were taken, and they were experiment of controlled microbial incubation. For both frozen and unfrozen conditions. And obviously, what was observed is that methane and CO2 production rate increased upon thawing. But also, Laura and the others noted that there were production of methane and CO2 even if the samples were frozen. So the little bugs were able to, obviously, microbes are super resistant to extreme conditions, and they're able to produce greenhouse gases even under frozen conditions. Second paper is reports the work of Dan Westley, a PhD student at SFX under Dave Risk supervision. And he was working on ground truthing the characterization of atmospheric methane release from degrading permafrost. And this was to ground truth some measurements that were made by German organization from airborne measurements of methane fluxes. So he did some walking transects for measure for measuring CH4 concentration over different permafrost conditions. And the results, they showed that he was obviously working close to some of the hotspots where methane was emitted, was measured by where airborne measurements were made. So it shows that there's considerable regional variability, and that the CH4 sources are not only biogenic but also thermogenic. We all know that in this area of the Mackenzie Delta, there are major gas fields underneath. And but the most prominent sources of CH4 emissions were located beneath thin degrading permafrost. So when we say thin, it's about 50 to 60 meters up to very level permafrost. So this is the region that has the highest potential for atmospheric release of methane. The other work that I want to report is the work by Charlie Paul at Mbari. So just looking at this is the schematic cross section. If we focus at the shelf edge, what's happening? We have groundwater discharge that occurs at the base of the permafrost and goes up to and vent at the seafloor. And what it does, what it forms are those big holes that are created by degrading offshore permafrost. You see that the difference in over 9 years, that those big holes where you could put the White House in easily has formed. And this is something that wasn't suspected, and especially the temporal signature to be so great over such a short period of time. That was very something that is new, and that we for sure didn't suspect it. Other work by Ehsan Bouzouki, from a PhD student at the INRS. It was he designed a laboratory setup where simultaneously we could acquire CT scan images, acoustic measurements, and electric measurements in real time. And what this led to was the emergence of a new concept, which is a thermal bridge concept, where we see that coarse sediments of where permafrost is hosted is more efficient at transferring heat because of the contact of the more important superficial contact of those grains. So permafrost degradation is influenced obviously by heat transfer, and it's more prominent in this context. Lastly, the work of Jefferson, that was a PhD student at the time at Polytechnique Montreal, who's now part of the GSC. And he used some deep learning approach to invert seismic data and look at the different condition of permafrost. And now it is reflected in the inverted seismic data. So I'm running out of time, so I'll go quickly on this one. But just to show that, yes, seismic data are a powerful approach to study changes of permafrost conditions, and especially guided waves. And that's what was mostly used in Jefferson's work. And we know that guided waves can be a good way of documenting or estimating the depth to the permafrost thickness as well. And we also know that from Jefferson's experiments that those P waves are losing their sensitivity as the permafrost layers either deepens or becomes thinner. And quickly, this is just the conclusions that was reported in the previous slides. So if you want to read those out, and I just want to finish on just to say that although I presented 5 papers, there's still much more, and there's still 4 or 5 more that are going to come out of this project. And again, thanks to the external collaborators with who we couldn't get that much outputs.